Good afternoon, good morning, and good evening. Thank you for joining us today for the what, why, and how of process mining webinar here at Decisions. We'd love for this webinar to be interactive today. So if you have any questions, feel free to use the Q&A interactive feature here in Zoom to post your questions, and we'll address them toward the end of the webinar. Thanks again for joining us. My name is Chase Macri. I am the marketing manager here at Decisions, and I'd like to also welcome to the stage Josiah Ilgenfritz, Senior Solutions Architect here at Decisions, as well as being our resident golden beard. And I'd also like to thank Ali Ostavar for joining us today as our Director of Process Mining. Ali will lead us through the demo a little bit later in the webinar today. But before then, we'd like to have Josiah tell us a little bit about process mining. Hey, Josiah.
Hey, Chase. Thanks a lot. So let's go ahead and dive right in and talk about what is process mining. Process mining is an area of study that sits between business process management and data mining. When we look at the data that drives a process from the side of here's what the process is to here's a bunch of data about the process mining sits in the middle there. And it's a discipline that allows us to uncover hidden patterns and trends by analyzing large amounts of that raw data to help us optimize the business process and the outcomes by improving the efficiency, effectiveness, and productivity of the workflows that make up your process. Process mining as a discipline, we can trace its start all the way back to the 60s. But it's not until the early 2000s when we started to see computing power and algorithms that were actually able to take that raw data and allow us to automate bringing it in and mining that data. Why do we need process mining? As kind of just a general example, I think everyone is probably familiar with the advertisements for a Big Mac. You see a commercial on TV, you see it printed, right? The Big Mac looks beautiful. It looks like the burger that you want to eat when you're hungry. You want to go and get that Big Mac. Many of us have also probably experienced what a Big Mac actually looks like when it's midnight and you're hungry and you go to a McDonald's and they give you something more akin to what you see on the right. Process mining helps us to analyze and understand the gaps between the ideal and the real of our process. It helps us to go from this is the thing that we think that we should have to this is the thing that we actually do have. So when we start to look at a process, if I talk to the business owner of a process and say, what is the thing that your process does? I may get something like this, a very streamlined step-by-step. Well, first of all, a user does this thing, and then a person does this thing, and then we do this thing, and then we do this thing, and then the process is done. But if we were to actually take a look at what the process is and what's actually happening, we might see something more like this, where there's multiple things that can happen. There's things that take time. There's things that slow the process down. There's things that cause the process to go unexpected places that we didn't think in our original estimate of here's what the process should be to here's what the process is. We've used process mining ourselves internally on some of our processes here at Decisions. We took a look at the process that drives our development tickets. We ran the data through, and when we got done, we fed it back to the owner of the process who looked at it and said, that's not our process. That's not what happens. But when we dug into the data and took a look at it, we realized that the streamlined expectation of what the process should be and what we thought was happening was different from the process as it actually happened. So process mining is the tool that allows us to go from the ideal, the understanding of here's what we think the process should be to here's what the process actually is. When this thing is out in the wild and people are doing it, here's what's actually happening.
Do we really need process mining tools to understand our process? I mean, you mentioned traditional approaches just now. I'm curious how it's better. What is the difference between traditional approaches like workshops and process mining, or from other techniques I've heard of like task mining? What's the difference there?
Absolutely. So looking at a process from a traditional approach, right? We want to understand what a process is. So we're going to sit down with a team of people and talk about what that process is and what it looks like. And so there's going to be a lot of manual work, sitting down, time taken, and talking through what that process is. That becomes very subjective. What you're going to know about the process is going to be what the people you're talking to know about the process. So if I'm the process owner and I say, here's what the process is, it's absolutely this, it's always this is what happens every time we do this thing, right? There could be a lot of reasons why I say that. One, I may think that that's how the process always works. Maybe it's a process that I designed and I'm very defensive about people doing the process the wrong way. And I say, this is how we do it every single time. Whatever the reason, there's always going to be human factors in what you learn about the process. And it's a very time consuming approach. Process mining, on the other hand, is automated. We don't have to sit down with a group of people to understand what the process is. Process mining is objective. It's driven by the data. We're going to give it a set of data that we've gotten from the process, and that's what we're going to use to drive the process. It's not based on what my understanding of the process is. It's based on this is the data of what the process has been doing. It also eliminates the need as the person doing the discovery to understand what the process is. I don't need knowledge of the process to run the process mining analysis. I can pull in the data from logs and I can look at what the process is, and I can see that layout of here's what the process does without having deep understanding of the process myself. And it's much faster than sitting down and talking to people to understand the process. Now, Chase, you also asked about task mining. What's the difference between process mining and task mining? Process mining is going to be the analysis of the process from start to finish to understand how long each step takes, who the players are, what the process does at a macro level. Task mining is more akin to something like an RPA process where you want to understand the thing that a person does when they do a particular activity. And this could be something like using keyloggers to understand as a user, I come in and I click on this button, and then I click on this button, and then I click on this button, and that's the task. Task mining allows you to gather that data. Process mining allows you to look at the process and say, here's what's happening as my process happens. So let's take a look a little bit about how Forrester looks at process mining and how it comes into play, right? We can see here they've broken it down in kind of 5 steps of discovery, analysis, documentation, reengineering, and automating, where process mining sits at that discovery and analysis level, where we can see here's what the process is, here's what the process is doing, and then document that and use that to drive changes to the process where there may be inefficiencies, and to drive automation to help make that process run better. So we can say we've done the analysis, we see here's where there's bottlenecks, here's where there's things that are being done by a person that could be automated to help us gain time, save money, just reduce overall overhead. Whatever that may be, it identifies key places where we could automate the process and make it better. So what is it that makes process mining possible? Every interaction that your business processes to perform information in things like ServiceNow or Salesforce, or SAP, it leaves behind a trail of activity or a digital footprint of what's happening. In decisions, maybe you would see this as like your log files or some of the tables that govern the state changes as your process as it goes through. But because this digital footprint has a certain pattern or a certain structure, we can aggregate these things to build up a model. So the first step of process mining is for data engineers to collect that digital footprint and organize it into what we call an event log. These event logs can then be brought into Decisions process mining tool or whatever process mining technology you may be using to define the process and see what the process is based on the event logs. Once you've got that data collected and you've brought it into the process mining tool, then the analysis can happen. We can take a look and see what that process is, how that process functions, and places where, in step 3 here, right, we can see what we may need to improve about the process. Things like pain points or optimal pathways, places where we deviate from the optimal pathways, or the business outcomes of what the process is. Now that we've got this, we can find those pain points. We can see how to improve those pain points. And once we make that improvement, we then go into step 4 of monitoring the process, using the process mining tool to continue to monitor the process and see the key metrics and how we stay in compliance with the process as it's meant to be. And that drives us back into collecting more data, analyzing that data, finding additional places to improve, monitoring, and the circle continues as we continue to move through and have more and more data about our process and make more and more improvements to the process, more automation to the process based on those changes. So how is it used? Historically, you look at the data here that we've gathered from Gartner, process mining has been a tool that has been used to discover the process. As we saw in some of the previous examples and as we've been talking to it, we had that left side where we had the very straightforward, this is what the process we think it is, and the right side, here's what the process actually is, gathering and discovering the process. But we've seen the trend has actually been moving from just discovery of the process to enhancing the process. And this could either be fixing places where there are bottlenecks in the process or just improving the process, finding new automations, making the process better. But that trend is a trend that we've been seeing in the process mining tool that we've been moving more and more as people have started to, they've discovered their process. Now we're moving more and more into using the process mining to drive enhancement. And we've also seen a shift in the organizational impact of the process mining tool. Historically, we can see that it's been used a lot in business process improvement, which is great, but we've also seen it taking more and more hold in business automation, digital transformation of processes, and in IT operations, finding more and more ways to improve and enhance the processes.
Interesting. So there's certainly value in process mining, I can see that, but where can it be applied? Are there certain industries which benefit from it more than others? There must be some sectors or companies or even processes that are so unique that they could never work with process mining. Is that right?
That's a great question, Chase. What we've seen is that process mining can be used across a host of industries. Depending on what you're doing, you surely have some type of process, regardless of what industry you're in. Now, we have seen, as you can see from the graph here, the banking, financial services, and insurance takes up a big chunk of that, manufacturing taking up another big chunk of that, both of those around a quarter of the stakeholder there. But things like healthcare and IT and telecommunications, those industries also having a large presence of using process mining. But really, the tool is industry agnostic. It can be used across industries based on what processes you have that may need to be analyzed. And who are the key players when it comes to doing the analysis? And who benefits from that analysis? Starting at kind of the bottom level there, right? Unlike traditional automation, process mining is less about gathering the data than it is about the analysis. But that being said, you do still need to gather the data, right? And that's where your IT or ops, data engineering teams come into play, is the first step is to get the data into the tool. Now, if it's something where you're using a pre-built connector, maybe that part of the work is as simple as setting up the connection to get the data in. But maybe your data is not in a place that's just we can automatically connect to, and we actually need to build out those event logs. In that case, it's going to be doing things like writing a SQL query to get the data from a table, or wherever it may be that your data is stored, and getting it into a format that the tool can actually ingest. The next level there is going to be the business analyst. And this is the user who spends the most time actually in the process mining tool. They're the ones that take that data from the IT and ops people that they've gathered and bring it into the tool and do the analysis to discover what the process is, how the process works, places that the process can be improved, and whatever it is, whatever the data that you're trying to gather from that analysis, that's going to be your business analyst doing that work. The next level here is going to be the business owner. And this is going to be the primary stakeholder who is getting the benefit from the analysis. They're the ones who own the process and want to be able to make the process better. So taking that analysis from the business analyst and understanding how it applies to their process and places that they can improve their process, that's the big benefit there. And of course, you have your executive leadership who benefit every time the processes that they oversee are improved and drives that return on investment to help make the company function better. So as I said, the ability to use process mining really is going to be based on the processes that you have. And there's a lot of different processes that can be mined. Here's a few of the common ones. But like we talked about, the process is driven by having data that you can bring in an event log. So having some type of digital process or digital footprint to your process is going to be the key factor on whether or not your process can be mined. Let's talk about for decisions, for example. If you have you're using decisions and you're running a whole bunch of rules, but there's not really any state-driven transition or overall workflow, there's not going to be much to mine. But let's say you're using some type of overall process and you've got something like a case entity or a process folder that moves from state to state to state at given points and has people that do work on it, or you're using any type of assignments and decisions, that data can all be pulled out and fed into the process mining to analyze how your process is working. You've just spent a long time building this thing in decisions. Let's make sure that it's going the way that you want it to go, that you're getting the ROI from it that you think that you should, and use that to drive additional places where your process can be automated. So what are some of the benefits of process mining? What we see is the objective analysis from your data allows you to look at your real processes and identify things like compliance issues, performance issues, process improvement opportunities. We can see these things. Here's things that are causing problems or things that could be better. And we can use those to drive new revenue, more efficiency in the process, and increased risk reduction of the overall process. Maybe you've got a sales team who's just reconfigured their sales process in Salesforce, and they want help understanding what the process is, how long the process takes, who are the key players, who is the most efficient person on the sales team, who's the person on the sales team who's overloaded and could use some additional help. We can use the process mining tool to analyze the process, look at it, and then find ways to improve it.
These are great. I can definitely see the value. I'm curious, though, the examples sound a little hypothetical. So do we have any real world examples you can share?
Absolutely. The first example I want to talk about is an insurance claim process. Insurance company had two types of claims. They had simple claims that had not a lot of details, and they had complex claims. And their theory was that the simple claims that were coming through would be able to be worked faster and done more quickly, and the complex claims would be slower and take longer to get through the entire process. When they did an analysis of the process using process mining, they found that this wasn't actually the case. They made an interesting discovery. They found that the KPIs for the employees that they were working to was to get through as many cases as possible in a day. So what would happen is that an employee would come in, they would have one of these simple cases, they would open it up, they would take a simple, easy follow-up action, move on to the next case, but didn't actually do anything to really move that claim forward in the process and get it completed. Because their KPI was touch as many of these claims as you can, so it looks like you're doing a lot of work. The company's KPI was to complete as many claims as possible. So there was a misalignment between the KPIs of what the employees needed to do and what the company as a whole needed. So using the process mining, they were able to discover this discrepancy, and they were able to rework the process to say, instead of try to do as many claims or touch as many claims, the goal was now to close as many claims. They were able to rework the process to say, for these simple claims, instead of taking this follow-up action, actually work the claim, get the claim done. And they found that they were able to take claims that were previously taking between 30 to 60 days down to 1 to 5 days for an incredible cost savings. Another example is a software company that was building university grade management software. They were servicing a majority of Italian universities, and they had some SLAs for the delivery of their tickets, whether this was from one of their customers raised a ticket with a bug or a new feature. They had SLAs for how quickly they needed to get that ticket resolved and solve the problem. What they were finding was that most of their tickets were being resolved outside of the SLAs that had been set. So they ran the process through the process mining, and what they found was that the reason the SLAs were not being met was not actually from their development team. They were doing the work, and they were turning the ticket over to the university saying, this is ready for you to test or to implement or wherever it may be. And then they were getting no response. So their SLAs of how long it took for the ticket to be opened until it was closed weren't being met, but it was through no fault of their own. It was because they were doing the work, and then the ticket would sit there for a long time waiting to be closed because they weren't getting the response they needed. They also, while they were doing the analysis, found that while the company as a whole was using Jira to manage the tasks, they had a number of employees who were still using an older system to track their work. So they were also able to identify places to improve their process and get everyone on board with the new and updated way of running the process to help make everything more smooth and more efficient. And the third one that I want to talk about a little bit is the use case. Georgia Southern University did an analysis of their student information system request process. They analyzed a total of 890 cases, and what they found through that analysis was out of 890 cases, they had 420 different variations that process could take. So almost half of these things are doing their own thing. There's no standardization of the process. Over 890 cases, 420 different variations that they could take. And they found that only 7% of those cases actually followed the expected path from start to finish of what they were supposed to be doing. They also found that out of the entire process, 40% of the cases were slowed by just 2 specific states that the process went through. So they were able to identify 2 major pain points in the process that could be automated to help streamline and improve the process.
So process mining works across all industries and domains and can be applied to about any process we can think of. What data do I need? Is there specific file types?
Great question. So the data that you need, like we said, this data can come from a multitude of sources, a multitude of different processes. There's 3 things that we absolutely have to have. The first is going to be the case ID. As long as we have that log of here's all of the events that happened, the case ID says for each of these things that happened, here is the instance of the process that it belongs to. Next, we need to have the actual activity that happened. If you look at the data here, right, that first 2 rows, they have the same case ID. We can see that it was review and then apply. Those are the 2 things that happen. So we need to know what is the instance of the process that this data belongs to? What is the thing that happened? And then finally, we need to know when that happened. In order for us to be able to generate the process map of here's what the thing is, here's what the process is, we need to know the order the events happen and the time that it takes them to happen. We need either a start timestamp or an end timestamp. We need to know one point in time when this thing happened. If you've got both, that's even better. It allows us to then see how long each step took and how long it took between steps. But as long as you have one timestamp for an event, we're good to go. Now, those three are the three things that you have to have. If you've got other data, like the resource, who it was that operated on the process at a given point of time, we can draw even more data out of the process to say, here's how the process relates as it moves from person to person, or here's how the process relates as in this person is slow, this person is fast. What is the impact on a human level on the process? And then other data as well that you may have to bring in, things like the cost for each particular step, so we can run cost analysis on the process. And then any additional attributes that you may have. If you've got a sales branch in New York and a sales branch in Washington, D.C., and you want to know the difference between the process between those two branches, as long as we're bringing in that data so that each case tells us where it was located, we can then use that as part of the analysis to say, here's the difference between the process for New York, and here's the difference between the process for Washington. Or maybe the process is the same between them, but we can see that in New York, the process takes 2 days longer, or in DC, the process is 3 times more expensive. But having any of that data that we can bring in is going to allow us to get more insight from the process going out. What kind of data can we bring in to do the analysis? We talked a little bit about any of those pre-built connectors. So if you're using decisions, that would be something like a case entity or a flow execution extension. And in version 8, we have a connection already built. You can automatically move the data from the decisions workflow side of things into the process mining side of things. If you've got your data in Jira or Salesforce or ServiceNow, we have out-of-the-box connectors to those systems to ingest the data. If you don't have it in one of those places, as long as you have your data in a CSV or Excel file, an XCS, JSON format, or BPMN, we can pull that data in to do the analysis.
Well, now I'm excited. I'd love to see what it looks like in action. So let's bring Ali up on stage and have him walk us through the demo. Hey, Ali.
Hi, guys. Nice to nice to see you on Zoom. So today I'm going to show you a short demo of the platform. So let me sign out and start from scratch. So this is basically the platform is a web-based platform where you can basically install it on a laptop on your local server or in the cloud, and let's say install it, and it can be accessed by if you want analysts, by multiple people using it at the same time, doing different analysis, sharing data, and so on. So what you see here is basically a repository. In the repository, you can store event logs, you can store process models, and you can store any other artifact that you basically create as a result of your analysis. For example, you create a custom dashboard, then you can store it here and you can access it in the same repository. So the repository has a bunch of typical basically actions that you can perform in a repository, something similar to Google Drive. For example, you can move, copy, delete, and so on. You can also share. So the sharing basically allows you to share a project or a data set or a process model, whatever you choose, any artifact you choose. You can share it with multiple people. And let's say multiple people perform analysis on the same project and they share their insights and so on, right? So now what I'm going to do, I'm going to basically import the data and see some analysis in action. So you can, for importing data, you can import a set of formats. For example, apart from the process models, of course, different process models that you can import. You can import the event logs from a CSV file, from an Excel file, from JSON, and so on, right? Or you can also connect directly to a connector and basically pull the data from one of the connectors that exist. For example, if you're already using the decisions automation platform, you can automatically import the data from decisions. Here you can choose if you want to import live data, where basically data that gets updated automatically, incrementally, or you want to pull a data that is, let's say, from last year, and you just want to put a historical event, right? You can import, and basically it pulls the data for you automatically. So you can say what are the processes that I want to import, and so on. So these are the processes that I have in my decision automation platform. Basically, it lists them for me here, and I can choose which one I want to import, and I just click a button, and basically imports it for me. But now, today I want to import from a file because, yeah, I have some toy processes in the decisions, but I want to import from a more like maybe more meaningful process. Here, I'm going to import from a CSV file. So what I can see here is basically my data in the CSV file. So as it was mentioned by Josiah, is actually we need 3 data attributes that we need them for process mining so that we can do process mining. So it's like they are required to have. Now, before I explain them and how I can add them, I need to say that this is a process from a garage car repair. Basically, there is a garage, cars enter the garage. There are a sequence of activities that are performed, the sequence of repairs that are performed on each car, and then until the car goes out of the garage, right? For example, taking a look at the first record represents a certain activity that was performed on a certain car. So the activity was inspect damages. So we first inspected damages of the car. The activity was performed by a person named Josh. And the data also specifies the activity was started at this time and was completed at this time, right? Now, the activity was on a car, which was the brand from the brand Mercedes, right? And it was performed on a luxury garage. Now, obviously, there were a sequence of activities that was performed on this particular car. And how can we glue all these activities that were performed on this specific car? How can we glue them together so that we can create a case out of these executed activities? We do that using an ID, which we call a case ID, right? So this is the ID of this first car. The ID is, let's say, 9. So as you see, the second row has the ID 9, which means these 2 activities were performed on the same car. And also the third row and so on, right? You see all these activities, for example, inspect damages, then prepare estimate, and so on and so on. They were performed on the case with the ID 9. And now, after that, we started another case whose ID was 39, and we performed a certain number of, let's say, activities on them, on that car, and so on. So now we know what is the case ID, what is the activity here, and also what are the timestamps. So what we need here, first of all, we need the case ID. We need to tell the software which column represents the case ID. We need to tell the software which column represents an activity, and I'll just do that with dragging and these labels on top of the columns. I need to tell the software what is the start timestamp. So obviously the system automatically detects the pattern corresponding to the timestamp. You can also do it manually if you want, but usually the automatic detection is successful. So, and then we can specify the complete timestamp, which basically when we completed the execution of an activity. And now we are good to go for process mining now, but obviously, the more data attributes we add, the richer our analysis becomes. So here I'm going to add a bit more attributes. So I'm going to add resources, which basically was the person who was performing the activity. I'm going to add some other attributes. Here, I'm going to add this attribute as a case attribute. A case attribute is basically an attribute that is specific to a case. Basically, its value does not change across different activities that are performed on the case. For example, the brand of the car was Mercedes. No matter where we were doing inspect damages or prepare estimates, the car brand doesn't change, right? So again, the garage is another case attribute. And the price that we charge for that case is another case attribute because it's specific to the case and not a certain activity that we perform. And now there are other attributes that we perform here. I can just, instead of doing them manually, I can say that all the untagged columns, I want to import them as event attribute, basically attributes that are specific to activities and not the whole case. And this gets tagged automatically. And now I'm going to, I'm good to import. I just press import. It asks me if I want to save this setting so that next time, if I want to import the same data set, I don't have to set this thing manually. I can just import saved settings and it will automatically tag them for me. I say, no, for this time, I don't want to save. And then it asks me, there are certain columns that are like very variant. Do you want to import them? I say yes. Here it allows me basically to order activities that are performed in a certain case. In case there are clashes in the timestamps, by default, we actually order the activities that are performed in the case. We order them based on the timestamp that they were performed in. But if there is a clash between timestamps, you can basically specify, oh, I know, since I know the process, this activity is performed before this activity, so I can specify some sorting rules, which will be applied in case there are clashes between the timestamps. So in this case, I'm not going to specify, I'm just press done, and it will basically build the process and will show me the process, right? So now the process is built. What I can see here is an overview of the process. What we see here, we call it the process map. A process map is composed of two elements. One is here, one thing, what we show you, the box here, is basically the activities that are performed. And then we also show some arrows between the activities. We call them handovers, which basically we hand the work over to the next activity, from this activity to the next activity, right? So here we can see how the process is executed, the sequence of the activities that are performed, and in which order. So apart from this, we can actually see much more than just order of performing the activities. For example, here, taking a look at this activity, paint vehicle, we can see that this activity, there is a number here, 791, as it shows in the tooltip, or we can see here, this number represents case frequency. So what is case frequency? Basically, it says that this activity was performed in 791 cases. Now, out of how many? Out of 1,000 cases that we are looking at here, right? We are looking at all the cases that are in the data, and that is 1,000 cases. Of course, there is a dashboard. I'm not going to go into it right now. I'm just going to go back to this plugin, and then we will, if we have time, we will look at dashboard as well. So you can see a lot of other statistics about the process. So we can see that this activity was performed in 791 cases. Or, for example, we can see that this handover was involved in 401 cases. So basically, in 401 cases, when we perform activity conduct unibody repair, then we moved and we perform activity conduct inspection. Now, we can also see something else here, which is in this case red for this paint vehicle, and I explain why it's red, and it is 4 hours and 10 minutes. So what is this? And again, as we see in the tooltip, is average duration, or also here. Average duration, basically, in average, it took us 4 hours or a little bit more than 4 hours to perform paint vehicle, right? We can also see that for the handovers. On average, it took us 3 weeks and 1 day to perform this handover. Obviously, we don't perform handover, right? We perform activities. So what does this 3 weeks here mean? It means when we performed activity conduct unibody repair and when we completed the execution of this, on average, cases that went through this handover, which were 401 cases, they waited on average over 3 weeks until they can we start doing activity conduct inspection on them, right? So they were queuing up here for an average of 3 weeks. So that already shows us there is a bottleneck over here, right? So now, why this is red and why this is green? We color code these handovers in relation to each other. This one is taking 2 minutes and 10 seconds, and this one is taking 3 weeks. So in relation to this one, this is taking much more. So that's so basically the handovers, when it comes to handovers, the handovers that take the most amount of time compared to the handover that take the least amount of time. So they color code it differently, and we highlight them with red. Those are the taking the most amount of time. And then we start from green to red, and then we have orange, for example, here in this case, which that takes something like, let's say, in between these two, right? So you can change the way you color code these activities and handovers. For example, you may say that, okay, this is taking let's say 3 weeks, but for me, 3 weeks is fine. So I don't want to highlight this with red. For me, this is fine. So if I am going to specify an SLA, I can say that the SLA for this particular handover is 4 weeks. Basically, I am okay if it takes 4 weeks, cases queue up here 4 weeks, so I'm okay. You can specify an SLA. Again, if there is time, I will show you. You can specify an SLA and then color code based on the SLAs that you specify for each of these activities or each of these handovers. And then you will see that this will not be red anymore, depending on the SLA that you specify, right? So now, before getting into that, let's take a look at this handover more closely. So here it's getting my attention, so I want to double click on it and actually see the distribution of durations of this handover. I can see that, for example, in 69 occurrences of this handover, it took from 1 month and 9 days up to 1 month and 19 days, right? So another thing that I can see here is basically assuming that the SLA is 3.2 weeks. So by default, the software sets the SLA to the average duration. As I said, you can change this. I will show you how. So it's 3.2 weeks. or is a little bit over 3 weeks. So if the handover, if the SLA is this much, this handover is violating its SLA in 51.1% of the cases, which is 205 out of 401. Now, let's take a look at also here. So here we can also see the distribution of people or resources who were responsible for performing conduct inspection, because as we know, we are waiting here because this is slow, right? Or we don't have enough people doing it, right? We don't have enough people doing it. That's why cases have to queue up here so that people get available so that we can do this. So now, who are those people who are performing this activity when we are reaching here? We can see that there are two people. We have Harry and Josh. In 57% of the cases, Harry is doing this activity when we are coming from this handover, and in 42%, it is Josh. Now, we can maximize this and see more information here. As I said, we can set the SLA. For example, I can set the SLA to 1 week. I say, if it takes 1 week, I'm happy. If it's more than 1 week, I'm not happy anymore. It's too much. So I want to apply and see actually if my SLA is 1 week now, over 83% of my cases are violating the SLA, right? You can see other information about this handover, for example, the average duration, how much was the minimum, the maximum, and so on. And you can also see the information about the resources here. I can also focus my analysis on, let's say, this red part, which basically is the part that I'm violating the SLA. I can apply, and I see that when I'm violating the SLA, 42% of the time, Harry is doing the activity, conduct inspection, and 32% is Josh is responsible. Now what I want to do is I want to actually focus on the cases where I'm violating the SLA for this particular handover, right? I don't want to look at the cases where I'm not violating the SLA for this handover. I want to focus my analysis on those cases that are basically problematic. So I can automatically apply a filter here. I can say filter using the selected duration for this handover. And what happens is that now my cases are filtered. And as you can see here, now 300 cases are selected out of 1,000 that we had initially. And in these 300 cases, this handover that we were looking at basically is now, it is violating the handover, of course, all the time because we focus on those cases. And now we can basically focus our analysis on the cases where this handover is violated. We can do further analysis and so on and see who is responsible, why this is actually happening. And, you know, we can do all the analysis on basis of these cases. Now, this is not the only filter that we can apply. We can have actually, we have a rich set of filters that we can apply, which allows better use of process mining. Basically, I can say, I want the cases where, for example, this particular activity is performed, right? I can say only retain cases where at least this activity is performed, right? And this will narrow down my cases to 127 cases and so on. Now, if I want to look at the filters that I applied, this is the last filter that I applied. This is the first filter that I applied, where I applied the duration filter on this handover and so on. So we have a rich set of filters that you can perform. For example, you can perform a time frame filter, where you can focus your analysis on a certain, let's say, time period. For example, I want to focus on from April 2020, and I want to go up to, let's say, January 2021, right? I can apply a filter here. And now I am only looking at 29 cases, right? So there are a bunch of filters you can apply here. Let me delete all the filters and go back to the initial data set. So now here we looked at one way of basically doing bottleneck detection by looking at the process and focusing our analysis on the parts that are highlighted with red or the parts that are basically more frequent, right? Another way of looking at the process and identifying the bottlenecks is something that we call process animation, right? So what is process animation? Basically, we want to look at the cases that were performed in our process in a live way, in an animated way, right? So what I want to do here is that I want to divide my cases, the cases that were in the garage, with the car that entered the garage, I want to divide them into two garages that I have. I have a luxury garage and I have an economy garage. I want to divide my cases between these two garages and actually see how cases that come from different garages, actually how they behave. How do they go through the process? Maybe so one of them is fast, one of them is slow. Maybe one of them goes through a certain part of the process that the other one doesn't go, right? So let's divide our cases into two groups. Here, I want to apply a filter. Okay, I'm going to select the garage. This is the data attributes. that if you remember, I selected the garage data attribute, which is a case attribute. Now, first, I want to say that I want to filter out the cases that are in the, that are in the economy, and I want to keep the case in the luxury garage. So I'm going to label this as luxury. And then I'm going to select a second variant, where basically I say other cases. Any case that doesn't fall into luxury is obviously economy. So I'm going to just name it economy. And I'm going to choose a color, let's say green for the economy and red for the luxury, right? So I can specify other variants, but let's just be happy with this two and just continue. So we specify done, and then we go to the something we call, as I said, process animation. So when we start the animation, let's take it forward to maybe a bit more busy period somewhere here. So what we can look at here, each of these diamonds that you can see is represents a case that went through the process, right? As you see here, the green one, which is economy garage, we have 616 cases that are from economy garage, and we have 384 which are from luxury garage, right? As you see here, for example, on this specific pass, we can see that there are a lot of economy garage that are going through this. And as if you remember, we kind of looked at this pass and we said that there is a bottleneck here, which is taking 3 weeks on average. And as we see the red ones, which are luxury garage, when they go through this pass, they're actually going faster, quite faster than the green one. So we can see that there is actually a difference in the behavior of the process, the cases, when they come from the luxury garage or economy garage. So economy garage is much slower. And as we can see, there is a difference between this behavior. So this basically allows us to divide or to group our cases into two different categories, into two different groups, and look at the way they behave in the process when they are executed in the process in kind of animation, it's kind of a live manner, right? So animation is actually basically is another way of looking at the process and see where the bottlenecks are, how the cases in the process, different type of cases, how they differ from each other when they are processed, and so on, right? So at the end, if you have any questions, of course, I will answer your questions about this animation. But for now, let's exit the animation. I don't know how much time we have. I think we have just a few minutes, maybe 2 minutes. So in these 2 minutes, I'm just going to show something very quick. I'm going to basically, what we are looking at is the abstraction of the process. We are obviously looking at the most frequent handovers. As we increase the slider here, the handover slider, we are going to see more and more handovers. So here we see that a couple of more handovers were added here. One thing that is important in the process map, there is one limitation in the process map in what we are looking at, is that we can see that there is a back and forth between these two activities. Sometimes we perform conduct unibody repair, and then we perform install new parts. And sometimes we perform install new parts, and then we go and perform conduct unibody repair. You see, there is a back and forth. So now one may think this is a loop. This is a back and forth between these two activities. So we are actually doing these two activities in a loop. We are doing them over and over again. But is that really the case? Maybe, maybe not. Why? So maybe sometimes we perform this activity first, and then we go and perform this activity, and then we continue. Or sometimes we may be performing this activity first, then we move to this activity, and then we continue from there. So there is no loop, there is no iteration, but rather there is a back and forth between these two activities, which indicates maybe these two activities can actually be performed in parallel, right? Maybe there is a parallelism between these two activities going on and not actually a loop. But we cannot see this from this process map, because what we see here, this back and forth, maybe it's a parallelism, maybe it's a loop. So process map has a limitation there. How can this problem be solved? We can click here, just by one click, we can discover something that has more meaning, a BPMN model. So now, if you're familiar with BPMN model, basically BPMN model has gateways, and gateways, which are shown here with these diamonds, basically show us the relationships between different activities. If we look at the same activities that we had there, conduct unibody repair and install new parts, we can see that there is a plus gateway, and in BPMN, plus gateway means parallelism. So actually, these two activities were not in iterations, were not in a loop, but they are actually parallel, so we can perform them in parallel. So sometimes this is finished before this, sometimes this is finished before this. And that's why we could see this back and forth. And this is one advantage of BPMN model. Now, BPMN model itself not only solve these situations for us, but can also be the basis for much more analysis, which we can do in the platform. But I think because of time shortage, I cannot go through them. So I don't know how much time we have, Chase.
Yeah, I think we're right at time to get a couple of questions. We had a few pop up here in the chat. I'd love to get your feedback on. One is from the repository server that you presented. The question is, does decisions need to be deployed using a SQL database connection in order to use it?
Sorry, 1 second. Does it need to be imported from SQL database connection? No. So long as your auto process is automated in decisions, you just with one click you can import it. Let me just show you very quickly. So I have decisions studio going on here. So it's just a simple process that I have created just for the sake of the demo. It's basically insurance handling, claim handling. Is a loan application process. Basically, you receive the loan, you check the loan request, and request additional documents. You issue a loan, or the loan is dispersed, or loan is rejected. So it's a very basic, simple process that I have created in decisions. Now, what I can do here, I can basically say I want to import data from decisions. So I have two processes. One of them is the loan request one that I showed you. I'm going to specify a live event stream. Basically, the data gets pulled automatically when there are changes. So I just import and says, okay, the import started. It will let me know when the import is completed, and it's okay. There's a message. The import is completed. So I just refresh, and I see the two folders here, each of them corresponding to one of the processes that they had. This is the loan request one. I just double click, and I can easily mine the data, and I can see my process as it was executed from the data over here, and I can start my analysis. So it's really as simple as that to perform your analysis, to pull data from decisions and just start doing the process mining.
Great. And one of the other questions was, how do you capture manual steps or transactions that don't produce logs or might not have a digital footprint?
That's a good question, and that's one of the challenges in process mining. Is that there are certain activities that you perform manually. Obviously, process mining relies on the data, and the data typically or usually comes from the information systems. So if the activity that you perform is not backed by information system, is a manual one, well, there are really only one thing you can do, and that is to enter the data into the system or into an Excel sheet, and at least the basic information. Let's say which case was coming from, the case ID, the activity that was performed, and at least one timestamp where the activity was completed, or something like that. If not both timestamps, then you can enter them manually, let's say in the Excel sheet, and then you can import the data. Obviously, we also have simulation capabilities. So starting from a process model, so I have a process model here, a BPMN model. I don't have any data behind this, but I can run a simulation, and by running a simulation, I can generate data, and I can save. Basically, I generate simulated data, I can save it, and I do analysis on the simulated data. It's not exactly like the data comes from the real execution of the process, but if I don't have any execution of the process, then at least I can draw my model, simulate it, and start doing analysis on a simulated data set.
Awesome, thank you. So before I let you guys go today, I just want to let you know that there's another webinar that we have coming up next month entitled Decisions for Life Sciences. No industry faces the same level of disastrous and potentially fatal impact of human error like the life sciences industry. Rising costs within the field see aggressive scrutiny, demanding solutions that alleviate costs. Our customers use decisions to eliminate some of those errors and reduce wasted resources, and we'd love to share that with you. It'll be November 10th from 11 to 12 Eastern time, and we'll demonstrate how our customers are improving patient experiences, reporting compliance, and master data management quality in the life sciences industry. And lastly, for joining today, all of you are entered into a complimentary process mining engagement where we'd work with you to examine one of your processes within the tool, get some results, and see how you can further automate and improve your business after looking through those results. We'll announce the winner next week. So mind your emails from events@decisions.com or sales@decisions.com, reaching out to you if you've won. And again, I'd like to thank you for joining. Really appreciate it. Thank you, Josiah. Thank you, Ali, for your time as well. And have a wonderful day.